This video is part 2 of Finding Unknowns. Okay, so the quick check here says, in an effort to promote their business, the Ooh La La Dessert Boutique provides customers with complimentary matchboxes to be used for birthday candles. So I've tried to draw this for you. Here is the box that we're concerned with. It's this logo box. Well, over here to the right, these are the matches that go inside there. So if you can picture this, this is empty. There's nothing here. On the other side here, those are just empty sides so they can slide the matchboxes in there. So the company places their logo on the outer box that has no ends, and they use 132 square centimeters for this logo box right here. And so looking at this and trying to figure out the best way to do it, I think it's better to not use a quote formula like normal, because I'm looking at that box. It's a rectangular prism which usually has 6 faces, but 2 of the faces are missing. And so it has a length of 12 and it has a width of 4. So this height, this would be called the height right here, that is the part that's missing. So what I'm going to do is I'm going to take the 4 sides that are there and write the measurements of those 4 sides and add them together. Okay, so hopefully that makes sense. So the front of this box where the logo is right here has dimensions of 12 and 4. So 12 times 4 is 48. So that is 48, and these are centimeters. And then the back of the box is congruent and parallel, so it is also 48 centimeters. Then the other part of the box that we have is, well, we have the top and the bottom. And so this is 12, and then this measurement right here is the X that I don't know what it is. So 12 times X is the top, and then we have a bottom that's 12 by X. And then the other 2 sides are just not there so that we can slide the matches in. So what I do know is when I add up these 4 dimensions, so 48 and 48 is 96, and I add that to 12x plus 12x, which is 24x, I get a total of 132 square centimeters. So 100 and, sorry, my calculator's just a bit slow, 132 minus 96 is 36. So I get 24x equals 36. And if I divide both sides by 24, I get x is equal to 1.5 centimeters. And so that would be this x right here, or the height of that box. Okay, hopefully that made sense. It's a little bit different than some. All right, let's look at the next problem. One of the big things with these word problems is you have to read them and make sure that you're using the right formulas. And so a lot of times I double check my formulas as I'm using them. This one says a snow cone shaped like a right cone has a volume, it's a volume of 10.8 cubic inches and a height of 4 inches. What is the radius at the opening of the cup? So I have to think about what is the formula for volume of a cone. So volume of a cone, that should be 1/3. I'm going to double check. Volume of cones, yes, 1/3 BH. That's what my formula chart tells me. But I think, what is B? B is the area of the base. Well, the base of the cone is a circle. So I always change this to 1/3 pi r squared times the height. And they tell me that is equal to 10.8. So let's fill in what we have. We have 1/3 pi times the radius squared, that's what we don't know, times the height, which is 4, is equal to 10.8. Okay, so they tell me to the nearest 1/10 of an inch. So that means that I can go ahead and put pi into my calculator. Personally, I like to get rid of these fractions, and so I like to just multiply both sides by 3, just because not to deal with a fraction. So 3 times 1/3 is 1. And I'm left with 4 pi r squared is equal to 10.8 times 3. And that is 32.4. You don't have to do it that way if you don't want to. But now I need to get r by itself, so I'm going to divide both sides by 4 pi. If you're using your calculator, be very careful and put that in parentheses when you divide, or else you'll make a mistake. So 32.4 divided by parentheses 4 pi, and I get 2, sorry, my eyes are really bad right now, 2.58. So I get r squared is equal to 2.58. And so now I have to take the square root of that. And I get 1.6. So the radius is approximately 1.6 inches. Seems like a small cone to me, but oh well. Okay, let's go to the quick check. Now I would ask you to please pause this for a moment and see if you can't set this up itself. Let's see what's cut off. A candle shaped like a regular square pyramid has a volume of 108 cubic inches and a base side length of 6 inches. What is the height of the pyramid? Okay. So pause for a second. Okay, so we've got the same formula here. 1/3 BH. But the problem here is not a problem, it's just that the base is a square. So these are all 6. So this is going to be 1/3 times the area of the base, so just 6 times 6, which is 36, times the height, which we're looking for, is equal to 108. So 36 divided by 3 is 12h equals 108. And if I divide both sides by 12, I get the height is equal to 108 divided by 12 is 9. And again, these are inches. So the height of this pyramid is 9 inches. That wasn't too bad. Let's see what we have next. Okay. A rectangular fish tank, when filled halfway, has a volume of 9 cubic feet. So if we can't see the whole thing, but I think that's okay. So if this was cut in half, the volume would be 9 cubic feet. If the tank is 3 feet wide and 4 feet long, what is the height of the tank if it's filled to capacity? Well, if at half capacity it's 9, it would mean at whole capacity it'd be 9 times 2, or 18. And so this just becomes a rectangular prism, which is length times width times height. So 3 times 4 times h is equal to 18. So 12h is equal to 18. Divide both sides by 12. And 18 divided by 12 is 3/2, or 1.5. So the height of this fish tank filled to capacity would be 1.5, and these are feet. Sorry, my writing gets so bad on this. That wasn't too bad. All right, so now we get another quick check that I would like for you to pause the video, try and read it yourself, and see if you can't think about how to set this one up. I'm going to go ahead and pause this myself. Okay, I stopped at trying to draw the two pyramids the best I could. We have two square pyramids that have the same volume. For the first pyramid, the side length of the base is 20 inches. So that's the red pyramid. It has a square base that's 20 inches, and it has a height of 21 inches. The second pyramid has a height of 84 inches, and the second pyramid, oh, so yeah, this makes a lot more sense. I don't know where I got, let me clear, this isn't 21. Okay, that makes more sense to me now. Okay, so we have 20-inch base with a height of 21, a second pyramid with a height of 84, and we want to know what is the side length of the base of the second pyramid. Okay, so let's give this a, let's just call it X. That's what we don't know, but we know it's a square. So the formula for these are 1/3 area of the base times the height, and they're equal to each other. And we know that the bases are squares. So in the first one, we have 1/3 of 20 times 20, or 400, times the height of 21. And that is equal to 1/3 x times x, so x squared, times 84. So let's go ahead and simplify this left side. Let me go ahead and multiply that all together. I've got 400 times 21 times 1/3, or divided by 3. And that is 2,800. So I have 2,800 is equal to, I'm going to multiply 84 times 1/3, or 84 divided by 3 is 20, sure I can read this correctly, 28. Okay, so I have 28x squared. So I'm going to divide both sides by 28. So I can see what's going to happen here. 2,800 divided by 28 leaves me 100 is equal to x squared. And so if we take the square root of 100, we get 10. So x is equal to 10. So on the tall pyramid, the side lengths are 10 inches. Okay, so sorry about the pictures, but in these, again, usually the work is in setting it up and understanding what the problem is asking. We're kind of out of time, so let me see how much more. Let me see how many more we have. Yeah, I'm not going to finish, but let's go ahead to this one here. Find the height in the centimeters of a square pyramid with a volume of 72 cubic centimeters and a base edge equal to the length of the height. Okay, so let's see what we have. A square pyramid. So again, I do my best with my square pyramids, but something like that. Okay, it has a volume, so 1/3 area of the base times the height, of 72, and a base edge equal to the height. Okay, so that's not too bad. We got, this is x, and this is x, and the height is x, because they're all equal. So we have 1/3 x times x for the base times x for the height, which is x cubed, is equal to 72. So again, I'm just going to multiply both sides by 3, and 72 times 3 is 216. So I get x to the power of 3 equals 216. And again, the way I usually put this in my calculator is the opposite. You can do it either two ways. You can say the cubed root of 216, or you can take 216 and raise it to the power of 1/3, which is the inverse of whatever power it is. So if I put 216 and raise that to the power of 1 divided by 3, I get 6. And so x is 6. And I think I'm going to need to end this video right here before we run out of time, and I will put a third video of just the last few examples.